So in previous chapter, we have studied kinematics of a rigid body, and now we will consider kinetics of a rigid body. So we will relate force and acceleration and moment and angular acceleration. Okay? So it's very similar to what we did in chapter 13 for a particle, but now because we are considering a rigid body, then we should solve for two equations in kinetics. Sum of forces equal ma and sum of moment equals to ir. Okay, so this is the objective of this chapter. So to start with, because we are working with a rigid body, we should define what is mass moment of inertia. Okay, so the inertia is defined as the capacity of an object to oppose rotation. If you remember, when we said in the second law of Newton, sum of forces equal ma, the definition of mass of an object was the resistance of object to acceleration, if you remember. And here, to linear acceleration. And here, when we say inertia, inertia is defined as the capacity of the body to oppose rotation. Okay? So rotational motion is governed by equation sum of moments equals ig alpha, where inertia is about the center of mass of the object, and the second law of Newton for translation motion is sum of forces equal to mag. Okay, so to start with, we should be able to calculate the inertia. How to calculate inertia of a body? The inertia of a body is defined as integral r squared dm. Okay, you are not responsible of integration. You should only know inertia of common objects. So disk, cylinder. I will send you a formula sheet including the different known shapes for inertia. Okay, so حدا بعت لي Zoom is updating. You are not able to hear me. Are you hearing me?
Yes.
So no problem.
لا Professor he's not in the meeting. عم قل لك انه it's updating عنده. I think.
Okay. طيب. So what I want you to know is that you don't have to go through details of calculation. So you don't have to do integration to find inertia. I will give you the formula sheet, and for a common shape you directly calculate the inertia. So this part, if you want, of calculation of inertia by integration is not included, but it's just here for your information if you like to know. Okay, but I will not go through it because you are not responsible of it. Okay.
دكتورة.
No.
I was once reading بكتاب الماث.
Yes.
إنه the proof of this formula it goes من برهنة من الكايناتيك انرجي فورمولا هاف ام في سكوير لنعمل في انه نعوض الانجلر فيلوسيتي باللينير فيلوسيتي بالاوميجا بالكايناتيك انرجي لنوصل لهيك
مظبوط. بتبين الانتجرال ار سكوير دي ام ساعات.
هلا يعني معناتها انه وي كان سي انه الماس مومنت اوف انيرشيا انه هي منا كوانتيتي واضحه زي الماس بنشوفها او الفيلوسيتي ولا
لا هي ما بنشوفها. ما بنشوفها بس we can calculate.
شو بتعبر تحديدا يعني؟
نعم.
انه عن شو بتعبر بشكل تحديدا؟
بتعبر
يعني
عن الريزيستنس تو روتيشن.
بس نحن لما انه هي شيء بيشبه الماس هي انه اذا
هي انتجرال ار سكوير دي ام. هاد الديفينيشن تبعها. يعني هي proportional للماس و proportional للديستنس from the axis of rotation. Okay.
Okay.
So details of calculation of inertia انتم مش مسؤولين عنهم، بس مسؤولين تعرفوا الانرشيا for common shapes. Okay. So هول الانتجريشن هون رح أفيهم لأنه you don't have them. هلا I will write for you on Moodle which are the slides that you don't have. Okay. Now when we want to calculate inertia about an axis that is not passing by the centroid of the body, we can use what is called the parallel axis theorem. Okay? So here, for example, I have a body, and I know what is the inertia about the axis passing by the center of mass of this body. And now I want to deduce what is the inertia about any other axis. Okay, so as you can see in this figure, this is Z prime. This axis is passing by the centroid, the center of gravity, if you want, center of gravity. Okay, so this is axis. This is Z prime, and axis Z is an axis parallel to Z prime, but it's not passing by the center of mass. And we have a certain distance d. We have a distance d between the two axes. We can demonstrate now that the inertia about this axis can be related to the inertia about Z axis. How to do this? We go back to the definition. Okay, the inertia of a body about an axis is integral r squared dm. And here, what is r? If you take the distance from this axis to the elementary mass, okay, this distance can be divided into two parts. I can say that this distance is radical of y prime square, which is this one, okay, plus this distance square. This distance square is d plus x prime square. Okay, so if I replace in the equation, I obtain that the inertia about the new axis is integral d plus x prime square plus y prime squared dm. Okay, and now if I do the expansion, I can take integral x prime square plus y prime square plus 2d integral x prime dm plus d square integral dm. First, what is integral dm? What does represent? It's m. It's the total mass. Okay, so this term will give me m times d square, and I was able to take d outside of the integration because it's a constant distance. Okay, now what is integral? I still have to find these two terms. What is integral x prime square plus y prime square, and what is integral x prime dm? To understand what are these two terms, let's go back to the previous figure. First, what is, look at the figure. If you look at the figure, this is this is x prime, this is y prime. If I do x prime square plus y prime square, what do I obtain? Is the figure clear, or you want me to do zoom? Is this figure clear for you, or I amplify it more?
Can you amplify it a little bit?
Yes. It's fine now?
Yes, thank you.
Okay. Look, what is x prime square plus y prime square? In this
R
triangle,
prime square.
it's r prime square. Okay, so I can replace integral x prime square plus y prime square dm by integral r prime square dm. And what does represent integral r prime square dm?
The moment of inertia.
The moment of inertia about which axis?
Z prime.
Z prime. Okay, about axis Z prime. So now I can say that integral x prime square plus y prime square is inertia about Z prime. Very good. Now the second term is integral x prime dm. What will give you integral x prime dm? You remember how we defined the position of center of mass? If I tell you, give me the position of center of mass, what do? You say x prime g times the total mass, okay, equals to integral x prime dm. So I can replace integral x prime dm by x prime of the center of mass times the mass. But look here, what is x prime of the center of mass?
0.
0. Why? Because what is the origin of x prime, y prime, z prime? G. Okay? So x prime, g is 0 because g is the origin. So what will happen with this term, the second term? What will happen with integral x prime dm?
It will cancel.
It will cancel out. It will cancel out. Okay? And it will only cancel out if G is the origin of the frame. This is why you should pay attention that the parallel axis theorem cannot be applied between any two axes. You should have one of the frames having as origin the center of mass. Because if you don't have this, you cannot cancel this term. Okay? So the parallel axis theorem is always applied between z-axis, z prime axis passing by G, and any other axis z that is parallel to it. Okay? So we can deduce that the parallel axis theorem will tell us that inertia about z is equal to inertia about axis z prime passing by the center of mass plus md squared, where d is the distance between the two axes. Okay? So if you know the inertia about the axis passing by center of mass, you can deduce the inertia with respect to any other axis that is parallel to it by applying this form. Questions until here?
ايه بس ما فهمت انا ليه الانتجرال اكس برايم دي ام
هي
حولناها
زيرو.
لاكس بار برايم ام.
حولناها لانه نحن بنعرف اكس بار. What is x bar prime of G?
ما بعرف.
زيرو. مش x bar.
إيه
هي x of the center of gravity, center of mass.
مظبوط.
طيب وانت اذا بتطلع على الفيجر what is x bar of G؟ ما هو الاوريجن of the frame منير. G هو الاوريجن، يعني الاكس برايم تبعه قد ايه؟
زيرو.
اوكي. يعني ليش عملنا هيك؟
ليه حولناها لاكس بار؟ انه كيف حولناها من انتجرال لاكس بار؟
هيدي الديفينيشن للسنتر اوف ماس. انت كيف بتجيب الكوردينيت اوف سنتر اوف ماس؟ مش بتعمل اكس جي تايمز توتال ماس equals integral x dm.
اكس دي ام.
واذا بدك y، واذا بدك y of g شو بتعمل؟ y of g times total mass.
اوكي مظبوط. هلا انتبهت. سوري.
It's fine. حدا بقى عنده question on this part? Okay. So now, sometimes, okay, they can give us what is called radius of gyration. The radius of gyration is a quantity that will allow you to calculate the inertia. If I give you the radius of gyration about an axis, you can directly say that the inertia about this axis is equal to mk squared. Okay? What is the physical interpretation of radius of gyration? Can you tell me? Okay, look, I will explain for you what is the meaning of radius of gyration. So if you consider, for example, an object rotating about this axis, and the points of this object are all equidistant from the axis, okay? What will be the inertia of this body? For any point on the body, the distance from the axis of rotation is the same. It's k. Okay, so for any point the distance from the axis is k. So what will be the inertia when you do integral r squared dm? If r is constant, because here all points are equidistant from the axis, then the inertia will become mk squared, because when I do integral r squared dm and r is constant, I can take it outside of the integration. So I get r, which is k here. K square integral dm will give me k square times the total mass. So the radius of gyration is representation of a body if all points of this body were equidistant from the axis. So it's a body of equivalent mass, but with all points at one distance from the axis of rotation. This is the radius of gyration. Okay? So in real case, for example, if I take a full disk, the radius of gyration, of course, will be smaller or higher than the radius?
Smaller.
Smaller, because it's like an average value. Okay? It's an average value such that the inertia of this disk is equal to the inertia of an object of same mass with all points located at one distance from the center. Okay? So of course it's equivalent to a circle with a smaller radius where all points are at one distance, because it's like an average. So here you have points that are very close to the axis and others that are very far. So to find k, you know what do we write? To find k, for example, for a full circle, we write that inertia of a circle, you can get it from the formula sheet. Okay? Inertia of a full disk is half mr squared. 0.5 m times r squared. Okay? And the equivalent body for which all points are at one distance is a circle, is an empty circle. Okay? So it's a very thin, here you have a very thin layer, so all points are at one distance from the disk. So it's equal to mk squared. So from this formula, you can simplify the mass m. You can get k function of radius. So for a circle, we can deduce that the radius of gyration is equal to radical of 0.5 r squared. So it's 0.5 r squared to the power half. It's radical of this. Okay? So for each object, you can define the radius of gyration. Okay? And in general, if you have a shape that is complex, they can give you directly radius of gyration, from which you can calculate the inertia by doing I equals mk. Okay? Any questions on this? So, let us continue. Let us do a small example to practice on this.
بس مش بعدها هي زيتا ال distance between the axis of rotation مثلا
انت اذا الديسك is full كل البوينتس are equidistant from the axis. اذا عندك full disk if you have a full disk all points are equidistant from axis شيء no. Okay, بس انت you want to represent another object that is equivalent to the full disk. Okay, but having all points at one distance from the axis. هيدي الديستنس بنسميها radius of gyration.
Okay.
So the radius of gyration will be smaller than the radius of the full disk. لأنه it's like an average value اللي بتعطينا same inertia.
Okay. Thank you.
Welcome. So the following plate has a density of 8,000 kilogram per meter cube and a thickness of 10 millimeter. Determine its moment of inertia about an axis directed perpendicular to the page and passing through point O. Okay, so in this problem, they want us to find the inertia of this shape about an axis perpendicular to the disk passing by O, about this axis. Okay. So first, what should we do here? Who can tell me? What is the first step?
we find the moment of inertia about G and we
Very good.
apply the parallel axis
Very
theorem.
good. Why we start by G? Because the formulas which we have in the formula sheet are always about the center of mass. Okay, so we start by finding the inertia of my system about G, and then we do the parallel axis theorem between O and G. Okay, so first, to find the inertia about G, what can we do? We have, if you look here, you have a full disk, and we
circle
subtract.
كبير minus circle صغير.
Yes, we subtract from it the small circle. So you can do the same for inertia. So for inertia, it's the inertia of the big disk about this axis minus the inertia of the small disk. It's minus because it's a hole. Okay? So here, you know the formula for a disk. Now we said, what is the formula for inertia of a disk about its center of mass?
half mr square.
Half mr square. Okay, so first we should find the mass of the disk. To find the mass, they gave us the density and they gave us the volume. So the volume is the thickness, which is 10 millimeter, times the area, the cross-sectional area, which is pi d square over 4 or pi r square over pi r square. Okay. But pay attention for units, because density is in kilogram per meter cube, so you should convert the volume to meter cube. Okay, so I find the volume of the big disk, I multiply by rho, I get the mass of the big disk. Okay, and the inertia of the big disk about this axis is mass of the big disk times r square, which is 0.125 meter. Okay, now for the small disk here, I do the same procedure. I calculate its volume. So I do the thickness times pi r squared. This radius is here is, oh, sorry guys. The small radius is 0.125 and the big radius is 0.25. Okay. So this is the small radius 0.125 and the big one is 0.25. So here for the small disk, I do pi times 0.125 square times the thickness, I find the volume. Then I multiply by 8,000, I find the mass. And once I find the mass, I multiply by half r square, where r is 0.125, to get the inertia. Okay? Now I do inertia of the big disk minus inertia of the small disk. I get the inertia of the whole shape about center of mass. Once I'm done with this, now I will move to parallel axis theorem in order to find the inertia about O. Okay, so what is the distance between G and O?
radius تبع البيج circle.
It's the radius of the big circle. Okay, so it's equal to 0.25 meters. So I can apply now the principle of theorem axis, parallel axis theorem. Okay, so this is the solution here. As you can see, first step, we subtract inertia of the big disk minus the small one. Okay, and then in a second step, to find the inertia about O, we apply the parallel axis. Okay, any question on this problem? Okay, now we will move to planar kinetic equations of motion. Okay, we will derive together what are the kinetic equations of motion. So planar kinetics of rigid bodies studies the motion of a body. It will consider rotational effect and translational effect. Okay, motion of the body is viewed within the reference plane, and all forces and moment on the body can be projected onto the plane. So نحن in this chapter we only consider motion in 2 dimensions. Okay, we don't consider 3D motion. So always you will have all forces are acting along one plane. Okay, and moments will be perpendicular to this plane because the axis of rotation will be perpendicular to the plane of motion. Okay, now we want to derive together what are the equation of motions in a frame XYZ? Okay. So first, for equation of translation, it's very simple. I apply the second law of Newton. I have sum of forces equals mag. This vectorial relation will give me two relations, one in x, one in y. So sum of x equals magx, sum of y equals magy. So it's very similar to what we have considered in chapter 13. Now, what is new in this chapter is equations of rotational motion. So we will derive together what are equations of rotational motion. To have the equation of rotational motion, we should assess the term sum of moments about any point. Okay, so I will do sum of moment of forces about any point of the rigid body, which is P. So I will put on P axis xy, and I will calculate moment of sum of forces about P. Okay, now for any small element, if I take any small element, on this element I have the external forces and the interactions with other particles. But as you know, for the interactions with other particles, we have always action reaction that will cancel out. Okay, so we will see that this term will cancel when we do the summation. So let us consider, if you want to do the summation of moment of forces about a point, we know that we can replace sum of forces by what? By MIAI. Okay, so we have R vectorial MIAI. So we can say that the moment of a force about point P is equal, instead of R vectorial F, we can say it's R vectorial MIAI. Okay, now what to do with acceleration of I? We know that any point on the body and P are 2 points on one rigid body. And for 2 points on one rigid body, I can relate them by what? By which relation? You remember, if I have 2 points on one rigid body, I can say that the acceleration of these 2 points are correlated. They are correlated by the following relation. Acceleration of point I is acceleration of point P plus alpha vectorial R minus omega square R. Okay, so now when I do the expansion of this term, okay, I have R vectorial AP plus R vectorial alpha vectorial R minus omega square R vectorial R. But you know that R vectorial R is equal to what? What is R vectorial R?
Zero.
Magnitude times.
It's 0. So this term will cancel out. Okay, so if I continue, now to obtain the expression of moment about P, I will replace R and the A by their expression. So we said that sum of moment is moment about point I is the elementary mass times R vectorial AP. What is vector R? Vector R is the vector position. So I can replace it by xi plus yj. Okay? And vector AP is the acceleration of point P. So I can replace it by apxi plus apyj. Okay? Plus, as we said, we have R vectorial, alpha vectorial R. So we replace R by xi plus yj. And as we said, because it's a motion in 2 dimensions, the axis of rotation will be perpendicular to the plane of motion. So since the plane of motion is ij, alpha will be along what?
K.
K. So I have alpha k vectorial R. I replace R by xi plus yj. Now I do the vectorial expansion. Okay? After doing the expansion and simplifying, I will get that the moment of the external forces acting on P, acting on I about P, is equal to mi times minus y apx plus x apy plus alpha r square. Okay? This is the moment of an elementary force acting on an elementary mass. If I want to find the total moment, what should I do? I should do summation of moments about P. So I should integrate this term. Okay? If I integrate this term, what do I get? So here, if I integrate this term, I have minus integral y dm apx, okay, plus integral over m x dm apy plus integral over m r squared dm alpha. Can you tell me why we have taken apx, apy, and alpha outside of the integration? Why we can take alpha outside of the integration? Is alpha varying with the mass?
No, it's a constant.
No, it's the same at any for a certain instant. For any elementary mass, I have the same alpha. Okay, and for the for this instant, for any elementary mass, I have same apy and same apm. This is why I can take them outside of the integration. Okay, now what is integral y dm? Who can tell me? هلا شفناها. What is, I can replace integral y dm by what?
y prime y prime times لا
Yes, y of g, okay? Y of g
y
is
g
the
y
center
bar
of mass times mass, and I can replace integral x dm by x of g times the mass, okay? And now, what is integral r squared dm? This is definition of what? Of inertia. So I will deduce that inertia about which point, guys? Integral r squared dm.
G.
p
P. Why P? لأنه R is the distance from the elementary mass to point P. So this term will represent inertia about P. Okay? So if I replace in my equation, I will get the following relation. As we said, we have sum of moments about P equals to minus y bar m apx plus x bar m apy plus ip alpha. Okay? So this is a general rule to find sum of moment of forces acting on a rigid body about any point P on the body. Okay? Now, in particular, what is the most interesting point in general to do sum of moments about?
G.
G. Very good. So, if I put P on G, what I will have? What will change in my
بتصير بس I ثيتا دبل برايم.
Very good. بتصير بس I G alpha. You know why? لأنه إذا أنا بحط P on G شو بتصير Y bar of G؟ بصير هو ال origin of the frame. If G is the origin of the frame, so Y bar of G will be what?
0.
0. And X bar of G will be 0. So I am left with IG alpha. Okay? So I will repeat. If I put P on G, let me go back to the figure so you can see. X bar Y bar represents the coordinates of G relative to P. Okay? Now if I put P on G, this means that G becomes the origin of the frame. So if G is the origin of the frame, so if P is on G, if P is here, then what will be X bar and Y bar? In this case, 0. Because X bar and Y bar represent the coordinate of G in the frame. And if I put P on G, this means that G becomes the origin of the frame. So X bar and Y bar will be 0. Okay? This is why the equation reduced to sum of moment about G equals to IG alpha. Okay? Now, let us continue. We will derive another relation together. Okay? So
بس نحن مسؤولين عن whole derivations.
لا بس تتفهمون انا عم بعملهم، انتم فيكم تطبقوا الفاينل ريزلت.
Miss, even
Okay.
for the previous
Okay.
one, you know the last formula?
البارallel access theorem.
No, the one before it, the one we just did with the origin. I don't know, the one you were just doing.
Yes, you
Okay.
just need. بس أنا I am explaining for you من وين إجت relation. بس لا you are not supposed to know the derivation. Okay.
Okay, thank you,
بس
Miss.
تعرفوا كيف إجت. Okay. So now we want to derive another relation. Okay. The other relation will involve. We will not have time to continue this. We will continue next time, okay? But for the next session, we will do review problems. You want to do review on chapter 13 or 14?
13.
Okay. So yalla, we will continue review on 13 after. I will open a new session. Okay?
بس في اسال سؤال بس قبل ما نكمل.
أكيد تفضل.
عم شوف بالكتاب هلا هون لما حطينا الام بي اي على الكي دايركشن يعني حولناها لسكيلر فيكتورز،